Okay, so for part B, it says, use the trapezoidal rule, which I've brought in from the formula booklet, with 3 intervals to estimate the cross-sectional area of the tunnel. Now look, this is quite nice because they've actually given you the different points. So they've given you the height of the tunnel at 2, at 4, at 6, and at 8, which is 0. So I literally just need to sub these numbers into this. Just to remind you guys how it works, what we do is we get the area of these trapezoids, as they're called, trapezia. But here you have essentially 1, 2, 3 trapezoids, although this one is essentially a triangle, but it'll work out the same way, and it'll get the total area of this kind of purple shape. It won't be perfectly accurate because it's going to be missing this, this, and this. It'll actually be too small. And then in part 2, we'll actually get the area using integration, which will be the exact area, and you'll see one is bigger than the other. The integral will be bigger. Anyway, so for the trapezoidal rule, we're going from 2 to 8, because a to b is 2 to 8 of y dx. This is approximately equal to a half times h. So h, it says, is b minus a over n. B is 8, a is 2, n is 3, because we're doing it with 3 intervals. So it's just 8 minus 2, 6 divided by 3 is 2. But it's basically this length here. So this length is 2. 2 to 4 is 2. 4 to 6 is 2. So anyway, it's a half times 2 times y0 plus yn. So y0 is our 2.4. That's our first y. And our yn is actually 0. That's our last y. So that's our first y is this height, and our last y is this height. So it's 2.4 plus 0. And then we do plus 2 times this y and this y, because there's only 3 trapezoids. So it's 6.4 and 7.2. 6.4 plus 7.2. If you want to see a more detailed explanation of why this rule works, you can watch my video on that topic. But now I'm just gonna solve this with the calculator. So this will give me, just be careful guys when you put in the numbers. I'll do 0.5 for a half times 2. That's 1 times 2. 2 brackets. So the first one is 2.4 plus 0, if you like. Obviously, you don't have to put in the plus 0. Then plus 2 times 6.4 plus, let me be super careful, it was 7.2. 7.2, close the bracket, press enter, and I get 29.6. 29.6. So this is an estimate of the cross-sectional area. So it's 29.6 meters squared. Part C, well, it breaks it into 2 pieces. So the first one is, write down the integral which can be used to find the cross-sectional area of the tunnel. So the integral is just from 2 to 8 of this, of y, which is minus 0.1 x cubed plus 0.8 x squared dx. That's just that's part I, and then part II is to just actually calculate this. So the area equals, I'm just going to put that straight into our calculator. You can go menu, calculus, numerical integral from 2 to 8, and I'll put minus 0.1 x cubed plus 0.8 x squared dx gives me 32.4. 32.4 meters squared. And I told you this would be bigger than this one because this is the exact area. It's giving you the total area under this black curve, whereas this one is just an estimate. It's giving us these, well, the area under these purple lines, which is clearly missing 3 pieces, which is the reason it's smaller. Okay, so that's it. That's the last question. This is the first exam, actually, because it's May 2021 of the new applications course, which is why this, as integration questions go, and for a last question of the paper, this actually isn't that difficult at all. But it's the first time it was in a paper, so obviously they didn't want to give you a really difficult integration question. But anyway, as I always say, if you get a nice easy question, take it. Don't complain about it. Anyway, that's it, guys, for standard level. Higher level, I'm gonna have to see you for question 3.